Have you ever stopped to think about space? Not the final frontier with all the rockets and aliens, but the actual space you're sitting in right now. It's the nothingness that separates you from your screen, your chair from the floor, and our Earth from the moon. It feels like, well, nothing. It's the invisible stage upon which everything in the universe plays out its part. We take it for granted, assuming it will always be there, silent and constant. But what if it wasn't? What if this fundamental fabric of reality, this thing we call space, could actually break, tear, or even collapse in on itself? It's a question that sounds like it belongs in a science fiction movie, but it tickles the very edges of what we understand about our cosmos. This isn't just a silly thought experiment. It's a gateway to understanding the true nature of our universe. Before we can imagine space collapsing, we need to get a grip on what it actually is. For a long time, we thought of space as an empty, passive box. You had 3 dimensions, up and down, left and right, and forward and backward, and that was that. It was just the void where things happened. But then along came a clever fellow named Albert Einstein, who completely revolutionized our thinking. He showed us that space isn't separate from time. They are woven together into a single dynamic entity called space-time. The best way to picture this is to think of a giant stretchy rubber sheet or a trampoline. This trampoline is space-time. Now, if you place a bowling ball in the middle of it, what happens? The sheet dips and curves. That's exactly what massive objects like the sun and the earth do to space-time. They bend it, and that bending is what we feel as gravity. A smaller object, like a marble rolling nearby, will follow the curve created by the bowling ball. That's why the earth orbits the sun. It's just rolling along the huge curve in space-time that the sun has created. So, gravity isn't some mysterious force pulling us. It's the shape of space-time itself. If space began to collapse, it wouldn't be like a building falling down. It would be something far stranger, far more profound. It would be the shrinking of distance itself. The meter that separates one thing from another would no longer be a meter. The very concept of here and there would start to lose its meaning. One way to think about this is through the concept of a false vacuum decay. Some theories in physics suggest that the vacuum of our universe might not be in its most stable, lowest energy state. It's stable for now, but a big enough nudge could push it over the edge, causing it to roll down to the true, lower energy state. If this happened, a bubble of true vacuum would form and expand at the speed of light, and within this bubble, the fundamental laws of physics would be completely different. What would this new space be like inside the bubble? It's impossible to say for sure, but it would be utterly alien. The properties of elementary particles like electrons and photons could change. The strengths of fundamental forces like electromagnetism and the nuclear forces could be altered. In such a universe, atoms as we know them might not be able to form. Stars might not be able to ignite. Life would be completely impossible. If a bubble of collapsing space were expanding towards us at the speed of light, the terrifying truth is, we'd have no warning at all. The front of the bubble would arrive at the same time as the light from it, meaning we'd be obliterated before we even knew what was happening. But let's imagine a slower, more cinematic collapse, one that begins to unfold gradually across the cosmos. What would we, the stargazers on this little blue marble, notice first? The initial signs would likely appear in the sky, as distortions in the light that has traveled for millions or billions of years to reach our telescopes. Astronomers would be the first to raise the alarm. They might notice that distant galaxies appear to be blue-shifting unnaturally. We know the universe is expanding, which stretches light waves and makes distant galaxies appear redder. This is called redshift. A collapsing space would do the opposite. It would squeeze the light waves, making them appear bluer. Suddenly, galaxies that should be rushing away from us would seem to be hurtling towards us at impossible speeds. This would throw our entire understanding of cosmology into chaos. So as the collapse of space gets more intense, its effects would ripple out from the farthest corners of the cosmos right into our everyday lives here on Earth. The first thing you'd notice, gravity would start acting seriously weird. Remember our trampoline analogy? Gravity is basically the curvature of space-time caused by mass, but if space-time itself starts to contract and warp, then that curvature will change in some really dramatic ways. What we feel as gravity would become totally unpredictable and chaotic. One moment, you might feel lighter, like the Earth's pull just got weaker. The next, you could be pinned down by a force several times stronger than normal. This kind of gravitational chaos would wreak absolute havoc on our planet. Just think about the oceans for a second. They're held in place by this delicate balance between Earth's gravity and the Moon's pull. If gravity started fluctuating, monstrous tsunamis, way bigger than anything we've ever seen, would crash across coastlines all over the world. And the ground under our feet? That wouldn't stay stable either. The huge pressure inside Earth's tectonic plates, which is usually kept in check, would get all messed up. That means catastrophic earthquakes and volcanic eruptions on a global scale, as the planet's crust buckled under the strain of these shifting forces. So, zooming out from Earth, the collapse of space would totally rewrite the elegant celestial mechanics of our solar system. The planets trace their majestic, predictable orbits because they're following those smooth curves in space-time created by the sun. But if that space-time fabric starts to contract and warp, those nice, smooth orbital paths, they'd become chaotic death spirals. Mercury, being the planet closest to the sun, would probably be the first to go. Its tight orbit would decay super rapidly as the space it was traveling through contracted. It would spiral inwards, eventually getting torn apart by the sun's immense gravitational forces or just swallowed whole. And the same fate would, unfortunately, await Venus and then Earth. Our planet's year, the 365-day journey around the sun, would get shorter and shorter. The sun would loom larger and larger in our sky, not just because we were getting closer, but also because the light from it would be traveling through less space to reach us. That delicate Goldilocks zone that allows for liquid water, it would vanish in an instant. The outer gas giants, Jupiter, Saturn, Uranus, and Neptune, they wouldn't be spared either. Their vast orbits, which have stayed stable for billions of years, would also begin to decay. Jupiter, with its immense gravity, is like the solar system's bouncer, protecting the inner planets from stray asteroids and comets. But as its orbit became erratic, this protective influence would just disappear. Even worse, Jupiter itself could get sent careening inwards, its path intersecting with the other planets, leading to cosmic collisions on an unimaginable scale, or even the ejection of entire worlds from the solar system into the cold darkness of interstellar space. And the sun itself, it would be under immense strain. A star is basically a balancing act between the outward pressure of nuclear fusion in its core and the inward pull of its own gravity. As the surrounding space collapsed, the external gravitational pressure would increase dramatically. This could cause the sun's core to compress, accelerating its fusion reactions. It might burn through its hydrogen fuel way faster than it should, flaring up to become a blue-white giant, scorching the remaining planets before its own structure failed. The heart of our solar system would be forced to tear itself apart by the very space it once commanded. Expanding our view to the galactic scale, wow, it reveals a catastrophe of truly mind-boggling proportions. Our Milky Way galaxy is this sprawling, spinning disk of over 200 billion stars, all held in a delicate gravitational dance around a supermassive black hole at its center. This whole structure, which took billions of years to form, would be completely undone by a collapse of space. The vast distances that separate the stars and the spiral arms would start to contract. The entire galaxy, a structure 100,000 light-years across, would begin to shrink. The result, a cosmic traffic jam on an epic scale. Stars that have been peaceful neighbors for eons would be drawn closer and closer together. While space is mostly empty, and stellar collisions are pretty rare right now, a collapsing space would make them, commonplace. Stars would smash into each other, triggering supernovae that would blast deadly radiation across the contracting galaxy. Nebulae, the beautiful clouds of gas and dust where new stars are born, would be compressed rapidly, triggering furious bursts of star formation that would quickly burn out as the galaxy basically consumed its fuel in a final, brilliant frenzy. And at the heart of our galaxy lies Sagittarius A, that supermassive black hole. This cosmic monster's gravitational influence is already immense, but in a collapsing space its power would become absolute. As the galaxy shrank, stars, gas, and dust would no longer be in stable orbits, but would pour into the black hole in a torrent. This would create the brightest quasar the universe has ever seen, an accretion disk of superheated matter shining with the light of trillions of stars as it was consumed. The black hole itself would grow at a terrifying rate, its event horizon expanding to devour an ever larger portion of the imploding galaxy. Ultimately, the entire structure of the Milky Way, and really all other galaxies, would be erased. The great spiral arms would fold in on themselves. The central bulge of old stars would be crushed together. The final state would be a single gargantuan black hole, containing the mass of what was once a majestic galaxy. The same fate would befall our galactic neighbor Andromeda and all the other galaxies in our local group. The universe, once a vast and sparkling tapestry of island galaxies, would see each of those islands collapse into an isolated point of infinite density, separated by a rapidly vanishing, contracting void. Faced with such an ultimate and honestly inescapable doom, the human response would be to turn to science. Could we predict it? Could we stop it? The prediction part is really where our efforts would focus. If the collapse is due to a false vacuum decay, like we talked about earlier, we'd be searching for the bubble wall. That's the boundary between our normal space and the collapsed true vacuum space. Since it would be expanding at the speed of light, we couldn't see it coming directly. Our only hope would be to detect its secondary effects on gravity or other particles before it arrived. Scientists would deploy our most sensitive instruments to search for clues. Gravitational wave detectors like LIGO and Virgo would be our frontline sentinels. They're designed to detect the tiniest ripples in spacetime. The approaching wall of a collapsing vacuum might create a unique and powerful gravitational wave signature, a crack in the cosmic fabric that actually precedes the wall itself. Particle accelerators like the Large Hadron Collider would also be crucial. Physicists would be smashing particles together with frantic urgency, hoping to spot any tiny deviation from the standard model of physics that might hint that the underlying properties of our vacuum state are unstable. Another avenue of research. Looking for seeds of decay. It's possible that microscopic black holes, created way back in the early universe, could act as nucleation sites for a vacuum collapse. These tiny black holes might evaporate over time through a process called Hawking radiation. Astronomers would frantically scan the skies with gamma-ray telescopes, searching for the specific energy signature of an evaporating black hole. Finding one, and seeing if its properties match those that could trigger a collapse, would be our only form of long-range warning. It would be a terrifying discovery, a cosmic diagnosis with a terminal prognosis. But could we stop it? The honest answer is almost certainly not. We're talking about the fundamental fabric of reality changing its nature. The energy required to halt a universe-wide phase transition would be beyond comprehension, probably more energy than exists in our entire galaxy. Pondering the collapse of space does more than just entertain our morbid curiosity. It actually serves a profound purpose. It forces us to confront the sheer contingency and fragility of our existence. We live our lives on a foundation we assume to be rock solid, but the truth is, the universe is a far more delicate and mysterious place than we can imagine. The laws of physics, the constants of nature, the very dimensions of space and time, they all seem to be exquisitely fine-tuned to allow for the existence of stars, planets, and ultimately us. Thinking about how it could all unravel really makes you appreciate the miracle that it holds together at all. This whole thought experiment highlights the immense scale of our cosmic ignorance. While we've made incredible strides in understanding the universe, we're honestly like toddlers splashing at the edge of a vast, uncharted ocean. We do not know for sure if our vacuum is stable. We don't know what happened before the Big Bang, or what lies beyond the observable universe. We do not know if other universes exist with different laws of physics. These are some of the biggest questions humanity can ask, and they remind us that the age of discovery is far from over. The universe is not a solved puzzle. It is an unfolding mystery, and we are lucky enough to be here to witness a part of it. The very fact that we can even have this conversation, that we can use mathematics and logic to model the potential end of reality itself, is a testament to the power of the human mind. We are a part of the universe that has become self-aware, capable of looking back at its own structure and questioning its permanence. This capacity for wonder, for curiosity, and for scientific inquiry, is perhaps the most remarkable phenomenon in the known cosmos. It's our greatest tool for navigating the mysteries that surround us, and for appreciating the beauty and complexity of the reality we inhabit. So the next time you look up at the night sky, or just consider the empty space between your hands, take a moment to marvel at it. It is not nothing. It's the dynamic, resilient, and beautiful fabric that makes everything possible. The thought of its collapse is terrifying, but it actually imbues the stable reality we experience every second with a sense of preciousness and wonder. Our universe is a grand and ongoing performance, and for now the stage is holding firm. And that, in and of itself, is a great moment in science.